This video discusses applications of variation. So the way that you set up a variation equation is the same as we discussed in the previous video, but now we're going to build on that. We're going to use the first sentence to write the general equation as we've done before. Then we're going to use the second sentence to find a specific number for k. Lastly, we'll rewrite the equation from step 1, including the found variable of k. So let's write an equation that describes the variation. A is directly proportional to both B and H. So this is the part that we're going to use to write the equation. A is directly proportional to B and H. So that means that we'll be multiplying k by both B and H. We get A equals k times B times H. Now we're going to use the second sentence to find k. A equals 10 when B equals 5 and H equals 4. So I'm going to plug those numbers into this A equals KBH and solve for k. That gives us 10 equals k times 5 times 4. So 10 equals 20k. Dividing both sides by 20, we get k to be a half. Now we want to substitute this 1/2 into the equation that we wrote originally for k, and that'll give us our answer. A equals 1/2 BH. Let's try another. W varies directly with the square root of g and inversely with the square of t. So this is a combined variation. I'll use the first sentence to write my equation. W equals k, and then varies directly with the square root of g, so we'll multiply by the square root of g, and inversely with the square of t, so we'll divide by t squared. Next, we'll use the second sentence to plug those numbers in and solve for k. W equals 20 when g equals 16 and t equals 0.5. Plugging in, we get 20 equals k times the square root of 16 over 0.5 squared. So that's 20 equals 4k divided by 0.25. I'll multiply both sides by 0.25. That'll give us 5 equals 4k. And then divide both sides by 4. That'll give us k equals 5/4, but I actually would prefer a decimal in this case. So we'll have that k is equal to 1.25. I'm going to substitute this number into my original equation. And the reason I opted for the decimal here instead of the improper fraction was because I didn't want to create a complex fraction by putting the fraction in the numerator of a fraction. We're going to get a final equation of W equals 1.25 times the square root of g over t squared. Now in our next two examples, we're going to solve applications of variation that involve an additional step and tell a story. The beginning of the problem starts the same. We're going to use the first sentence to write the general equation. We're going to use the second sentence to find k. We're then going to rewrite the equation from step 1, including the found value of k. And that's what we've done in the previous two examples. But then there's one more step. We're going to use the equation from step 3 to answer any questions that are asked. Also, the variables aren't told to us, so we're going to have to kind of strip down that first sentence to just the bare necessities and choose variables to write our general equation. Our first sentence says the height that a ball bounces varies directly with the height from which it was dropped. So I want to strip this down to the most basic words. We can strip this down to bounces varies directly with dropped. I did not want to include height in my important words, nor use h for one of my variables, because height was used for bounces and the height from which it was dropped. So I avoided that word. So let's start by writing our equation. Bounces varies directly with dropped. That'll give us B equals K times D. Now I'll use the second sentence to plug numbers in and find K. A tennis ball dropped from 12 inches bounces 8.4. So plugging in, you get 8.4 equals K times 12. Dividing both sides by 12, I get K to be 0.7. So now I'm going to write my equation by substituting this 0.7 in for K, and I get B equals 0.7 D. Now we use this equation that I wrote there in green to answer the last sentence. From what height was the tennis ball dropped if it ends up bouncing 56 inches? So they're telling us that the bounce is 56, so I'm going to plug 56 in for B. And then we need to solve for D. Dividing both sides by 0.7. We get D equal to 80. And then since it's an application problem, of course, we want to include any units. We get D equals 80 inches. Let's try one more like that. A chef self-publishes a cookbook and finds that the number of books she can sell per month varies inversely with the price of the book. Let's use this first sentence to write our equation. Again, we want to strip it down to the most basic words that we need to write our equation. And we can strip this down to sell varies inversely with the price. So let's write that equation. S equals K divided by P. We'll plug the numbers in from the second sentence into this equation and solve for K. The chef can sell 1,500 books per month when the price is set at $8. So 1,500 equals K divided by 8. We'll multiply both sides by 8. And we get K to be 12,000. Substituting that 12,000 into our general equation for K, that gives us the equation S equals 12,000 divided by P. And we'll use this equation to answer the questions in Part A and Part B. Part A asks how many books would she expect to sell per month if the price were $12. So for Part A, we'll plug 12 in for P. S equals 12,000 divided by 12. We can anticipate that she is going to sell 1,000 books. Part B asks, if the chef sells 1,200 books, what price was set? This time we're plugging 1,200 in for S. 1,200 equals 12,000 times P. Notice that we have a proportion here. So the first thing we should do is cross multiply. That'll give us 1200p equals 12,000. And dividing both sides by 1200, we get that the price must have been set to be $10.